Okay, so going through our examples again, we did look at the simple case where the customer will either purchase or not the product. And the churn case is coming up. Then we looked at the simple numerical example with the web page visitors who will become or won't become paid subscribers of different kinds. We also looked at what determines whether a movie is a critical success, a mainstream hit, or a box office bust. We saw briefly some things regarding decision trees on how to distribute your resources on decision trees and electioneering. And now the next thing we're going to take on is the real estate prices. So with this we will move to regression with decision trees and with regression, let's begin by showing like the end result. So here we have 42 real estate prices, and they have different information that's kind of determining that price. And we have our predictions. Some go a little bit off, some are very precise. So this is what we exactly do with regression usually. So this was the state where we had. Let's take some kind of stock time series where we have on x-axis we have time, we have those data points that are going like this, and then we put either something like this through the data, which is kind of a trend line which shows how the stock price is growing, and there are similar issues in regression as well that we faced in decision trees for classification. Because, for instance, through such data, you might more precisely put some kind of a line which is a little bit seasonal. You see, I'm going up and down on this trend a little. So you might put some kind of a better line through that, because you can see those seasons here on the data. It might be that the stock price is overall kind of raising, but as the years go by, it's raising more quickly during some seasons. Now, with the stock price data, for instance, or our building price data, there is always also the danger of overfitting, because, for instance, we can do such a thing that we can put this line absolutely precisely through that data, but that's no good, because that means that it has kind of overlearned. It has learned to replicate our data precisely, but when you give it new data, it will do extra poorly. So no need to put just the trend line through it, because that would learn too little. No need to copy the data points exactly, but because that would learn too much or kind of overlearn from this data. And as we move on to that real estate price case, we really are promoting cooperation between the IT department and marketing, because as you saw in the cases, it is becoming more and more pervasive. Now, the reason for that is that the following data that we are going to be now analyzing is going to come from Zillow.com. So Zillow.com is an online real estate database, and what we have done is we've went ahead, and the IT guy has created for us a Python program. A program in language Python, which goes to different addresses in Cambridge, Massachusetts, and these addresses are actually lined up all here: Washington 6, Manassas 21, Pearl 280, and so forth, and fetches their real estate prices. And it will fetch different variables like the zip code, the type being condominium, single family, triplex, multi-facility 2 to 4, and so forth, the year of building, the number of bathrooms, the number of bedrooms, the number of remaining rooms, and then the dollar amount of the facility being sold. So you can see really a lot of data. Some of it is like nominal, which has like a couple of different values. Some of it is has continuous values, like the year's number, and so forth. So, and finally, what we're looking for is predicting the amount. So once again, the ordinary way for us would have been to go ahead and just kind of fit the linear regression line, for that data. But we are now going to use decision trees. Once again, we're considering 42 facilities being on sale, and here are the prices. So let's pull that now into SAP PA and run decision trees on it. So here we go, file and new. CSV file is what we take, and it's zillow.csv, and we create the file for SAP PA. Then we take predict pane from up here. We go to algorithms and choose RCNR tree. We take its and next we take its configuration and configure settings. Then here we say that we don't do classification anymore, but rather we're doing regression. And the dependent column, remember it was in the regression, it was called the dependent variable. The dependent column here is the amount, the monetary amount, and the rest of it is the independent columns. So we are checking them one by one. And then we just run the whole thing with decision trees. Now the results are here. So first of all, here you see that next to amount we have the predicted amount that has appeared, and the other thing is that we are going to now go to the decision tree itself, and here is the root node, and it says that the biggest divider actually is the number of bathrooms. So if the number of bathrooms is less than 275, so 2 goes under that, 3 doesn't, then the next thing it looks at is the number of bedrooms. If the number of bedrooms is big and the number of bathrooms was small, so then it says that the price should be 1.2 million. But if the number of bedrooms is big as well, then we go on and we look at the construction year, and if the kind of year is if it's been constructed a very long time ago, then the price will be 852,000. But if it's a newer building, then the price will be 593,000. And let's look at the other part of the tree where the bathrooms number is over 2.75. Then it looks at the year. If it's kind of a newer building, then and there are more than 2.75 bathrooms, then it's essentially 2.3 million. And if it's an older building, it looks further. And if it's between 1920 and 1900, then it's 1.5 million. And if it's even older, then it's 1.1 million. So you can really see how the decision tree does linear regression. And now the other thing is that we look at the trend chart, and here are the different facilities and their prices. This is the real price. This is the predicted price. So here we have these as well. Really kind of predicting how to price our house, because we can now take a specific house that we're trying to price, run it through the decision tree, and get an estimated price based on how the market behaves. Now, as we draw close to the regression part, I would like to put forth some comparisons of regression trees with linear equations. So first of all, the pros of regression trees. The pros are that it automatically selects the most important variables. So if you don't have much theory to go on, what's influencing your house prices, then you can use this method well. You don't have to give the form of the equation. So what does that mean? It means that if you have like data here on linear regression, and you have it going like this, and this is the simplest form, simple linear regression, then you have to initially look at the scatter plot and figure out whether you're going to place such a line through it or perhaps such a curve through it. So you don't have to do that in advance with decision trees, so it's easier. In case of some data types, it's better to do those complex nonlinear relationships. So remember that early picture where we kind of looked at a comparison of decision trees and linear regression, and decision trees classification and linear classification. So the linear classification kind of could only draw a straight line through the data, whereas decision trees did such kind of boxes inside the data. The thing is, of course, that you can see that there might be some data that's actually better classified or regressed with the linear one, or there are even other methods. So it's somewhat always data dependent also what method to use, but it's good in case of some non-linear complex relationships, for instance. The interpretation doesn't require statistical knowledge. So for that we can really say that we just read those decision trees as they are and then get the results out. No assumptions about the distributions of data. So remember, with linear regression, when you do regression, not classification, with linear regression you have things like heteroscedasticity and autocorrelation and multicollinearity. So you had to watch out for all kinds of different warning signals. So for instance, this heteroscedasticity is no issue here. You don't have to look at the how the data is built up. Is it the correct data for the assumptions of linear regression to hold if you're interpreting the data? So easier in that respect. Now the cons are that it's harder to find a total effect of one variable on the result or the dependent variable, or one independent variable on the dependent variable. So with linear regression it's easy. You get your sales equals 50 plus 7 minus 7 times price. You get that, and it's easy to interpret. Now with this one, it's not that easy. So the total effect is hard to quantify, as well as the interpretation, and it needs sometimes, or rather, it usually needs large data sets to really give some prudent results. To wrap the lecture part up and then go to SAP GUI for a churn problem that we're going to consider next, to do that, I would like to say that we always need to know how to assess the results. So a model is always some kind of a simplification for a special purpose. So it's also good when it performs the function that it's designed for. For instance, for example, if a disease is present for only 1 out of 10,000 people, then if we make a model which says that everyone's healthy, then this model is 99.99% precise, which in turn doesn't mean that it's good for forecasting a disease. So this such an issue where you have a minuscule amount of one class and the overwhelming amount of the other, and you have to kind of make the classification good, is called the class imbalance problem. And it's also present in, for instance, retention, because not everyone goes away, or fraud detection. So for marketing, it's definitely a viable issue that you should consider. Or for example, when we come back to that web page development, it's you now know that the most important clients are coming through Google, which in turn will alter your advertising strategy for target sites to attract the highest quality traffic. We also know that for instance, the country of origin is not important, then if we have to buy that information from someplace through the fact which IP address is out there, then we might not do that. If it's something that's costly to acquire, we can alter our strategy in that respect as well.